Okay, so I will continue with the drag and the lift are the videos that you're going to be watching. There are 5 of them, and we're going to do it in class so that we are done with that thing. We're not going to wait for it. So let me start. First of all, this is from last time, and we talked about the drag. So what is the definition of a drag? It's a resistance force, right? Pulling back. So it's a force caused by the dynamic action of a fluid that acts in the direction of the free stream fluid flow, and it's pushing against the direction of the movement, of any object. We have multiple types of drags, and we're going to talk about them today and solve questions about them as well. So it's a resistance force tend to slow the motion of the body moving through the fluid, and that's how it looks like. And we talked about, the plane and the wing and how that is going to be slowing the airplane or not slowing it. So we did that, and then we looked at this formula, right? That's the force, drag force, and we say that D is the coefficient of drag. It's a unitless number, and index of the drag body can generate. Each body will generate a different, has a different drag, right? Coefficient. We have the fluid density, kilograms per meter cube, right? And then we have AP is the projected area of the body, and you can see that the drag force is directly proportional to the area. The larger the area, the larger the drag, right? And that's why we're trying to build smaller and smaller airplanes, except for Airbus, going with the huge big ones. But that is creating a lot of drag, actually. And then we have the velocity. The higher the velocity, the larger the drag force. And do you know that we have sonic, speed, ultrasonic, transonic speeds from the Mach 1, 2, 3. So the largest is when you get to 10. Have you watched the movie The Maverick? Oh, that guy gets 10. That's crazy. Mach, that's crazy. But that's what superheroes are for, right? In Hollywood. That's what okay, to learn some physics. Anyhow, so as I told you, the CD will be different from each structure for each body. And that's what we did last time. So the parachute has the largest one with 1.2. So it generates a lot of drag and slowing the motion. We talked about skin friction that causing drag. And we said it's a resistance due to friction between adjacent layers of the fluid near the body. Now, the reason why we are having the drag is that, this is, if it's normal, we have laminar flow. If you have roughness, you will have turbulence, and the difference between the turbulence of the different layers will create that drag. Does that make sense? And so that's one type of the drags, and that's called surface drag or viscous drag, right? Make sense with that? I will keep those names in mind because we're going to talk about them when we answer the questions. Now, that is if you have a plate, laminar flow will be at the beginning, but as the plate is getting longer and longer, the layers will get apart from each other, wider and wider the different distances, and that's going to create turbulence, right? And that fluid boundary layer of thin plate, and then the laminar boundary layers gradually becomes thicker, so they go away from each other, and that is going to create a lot of turbulence, and that's going to create drag. Now, here's the thing. If you have a difference, so what's going to happen is that you're going to have a difference in pressure here and there, correct? So the difference in pressure is something we call it form drag, because you have two different forms of the layers of the flow, right? So that's form drag. So you have viscous drag, which is resistant drag, and then you have the form drag. Does that make sense? How we look at that? All right. Now, what factors affect the magnitude of the drag of this friction? It is proportional to the velocity. We talked about that. Surface area, we talked about that as well. So larger velocity, larger drag, larger surface area, larger drag, larger roughness, larger drag, and that's why space shuttles, airplanes, all of them are made so that they are really, really smooth. And we can use this if you are, let's say if someone is swimming in the ocean with a very fast current. If you are wearing what do you call a swimsuit that is triathlon swimsuit, the long sleeves, all the body. If it's smooth, yes. So that is actually reducing the drag force and make you move faster. So roughness is important, and then viscosity of the fluid. The larger the viscosity, the larger the drag. Make sense? Now, this is what we call form drag. Again, if you have laminar flow of a fluid, and then you have an object, and there is a difference, so they will have turbulence behind it. The difference in pressure between the leading and the tail, the head and the tail, that's a form drag. Does that make sense? We're talking about these. Okay, then, so this is created by pressure difference. That is the form drag between the lead and the rear side of the body moving through a fluid. Now, for us biomedical engineers, anything you put in the blood flow is going to create something called form drag, especially stents, right? And if you have blockages in the blood vessel due to the accumulation of cholesterol, that is a form drag, and that's going to cause the platelets to explode, creating clots, and the clots will go to the brain, and we have a big problem with stroke. Make sense with that? Because of the change in pressure. That's the key point for the drag. Cool. Also, it's called profile drag as well, or pressure drag, and also it's a type of a parasitic drag. There are different types of these, but this is the most common one that we deal with. Now, this is a design to reduce the difference in pressure between the head and the tail of the object, and this is how we design actually the wings of airplanes to reduce the drag pressure. Make sense? The form drag. If it's spherical, the big difference in the pressure, that's going to cause a big resistance or drag force. So streamlined shape A reduces the drag by reducing the turbulence created at the tail edge, thus reducing the pressure difference, and that is going to reduce the drag force for us. Good. Now, what factors affect that magnitude of the drag force? Or the form drag, not the resistance, the form drag. We have the velocity, pressure gradient in the front and in the back, right? That makes a big difference for us. And also the size of the surface area proportionally is increasing the drag force. Now, the area that's perpendicular to the flow, which means it's this area, right? Here or there. That's why people try to have something like this to reduce the flow of any liquid right around it. So the head and the tail need to have some curvature. Make sense? If you reduce the area, you reduce the drag force. The perpendicular area that is to the flow. Make sense? We good? I know what that makes sense in resistance when you design stuff. Now, if you recall, if I like old cars. I have a 1981 Toyota Cressida that I'm going to cut the top and make it convertible one day. That's my retirement project. Now, old cars, if you notice them, they're always rectangular in the front, and that caused a lot of drag. But gas was cheap, everybody was happy, they liked the shape, aesthetic, nobody cares. Now it doesn't work this way. So now all our cars, they have a different shape in the front so that it is aerodynamic friendly. That's what we call it with that. Okay, to reduce that drag. Okay, now competitive cyclists, have you seen any of those cyclists that they have this weird structure on the bike that it makes it faster for them? And I've seen people actually laying like this on the bike, and they really go fast with that bike. Now all of that comes down to the aerodynamics. If you do this with the body, which is the crunched aero position, you reduce that drag by 10 times. That is a huge difference. And if they're competing for, something, professional, that makes a big difference for the players. Same thing, if you have the helmets as well, they do a lot of resistance. I don't know so for cyclists or cycling, I know the dynamics, but the thing that is confusing me is the people with the motorcycles, because they don't have the new designs. They still have the big bulky ones, and that actually create a lot of drag unless they're always going down. So people can injure their necks because of that. So there is a need actually to redesign that thing for motorcycles. I stay away from this. That's too dangerous for me. Okay, now elite swimmers, triathlon. That's what I was talking about. The wetsuit that reduces drag a lot, and also streamlining the position in swimming help a lot in reducing drag as well. Okay, now we have something called wave drag. Have you ever seen an airplane, especially a fighter jet, when they have this cloud around them with it go all the way quickly? That is called wave drag. And what happened is that because of the shock of the speed and the differences in the two fluids in the front and the back, you build like a wall, and you have this cloud here forming. Now this has to be in the supersonic speeds and transonic, with the big guy. When you are more than 8.8, the Mach 8 and above, you will create that. You will get this thing. Now here's the thing, that is pushing the aircraft really hard backward, And the first, when they start going to the sonic and supersonic, a lot of people died because that was crashing. They didn't design it in such a way that is good. And one of the things that also lead to that shock wave is the airplanes, they try to make them light, correct? Now, the problem, if the airplane go up and down just a little bit as it drives, it creates the shock. So that movement, the vertical movement of that, supersonic or high-speed object is creating the shock. And then that will crash. And that's what happened actually for Maverick. Do you know the first scene when he tried the new jet and then he went down and he found the kid and he said, "Are you from space?" No, like Maverick. Who like this guy? He doesn't die. He doesn't age. It's impossible. Anyhow, so let's keep moving. So that's the resistance created by the generation of wave and the interference between two different fluids. And when I say two different fluids, it could be the same air, but it's different densities, right? If it's different densities, that's different fluids. And then the wave drag is a drag, and that retards the forward movement in the supersonic and transonic flights. Make sense? We get? Now, this is not going to be useful for us unless you are swimming in a really, really very fast current in biomechanics, if you want to deal with something like that. And the other thing is that if, people who, what do you call the sport when they are hanged with a rope and they jump down a bridge? Yes. Now that actually could hurt people because of drag. If you don't do it, if you're not careful. So if you go down like this, flat, you're going to break something going down, especially in high elevation. You didn't? You have a strong heart to do this. Here's my advice. Before you get married or involved with someone, do this together. If he or she did that to you, well, you stay together. If they say no, well, you should rethink the whole process. I've watched couples do this. Really funny. It's really, really funny. One of them will be having fun and the other guy will be just like, I'm dead. Now that you need to keep. But if both of them are having fun, you need to question this. Yeah, taking notes, yeah. I married the absolute opposite of me. And that's why we're still together for 20 years. It's working. It's just fine. Anyhow, so what factors affect the magnetic wave? Again, the wave drag. So here's what we're going to do. Same thing, the vertical oscillation, I told you about this. If you go up and down, up vertically, across that current, that's dangerous with the flow. It's really dangerous. It creates that shock wave. Flight speed or swimming. And the thing is that when you have laminar flow, your velocity and the drag force will increase with velocity. This is actually for airplanes. And then at a point, between two velocities, the drag force go really down. Really, really down, because you are still in the laminar flow. Once you hit that upper limit velocity, you start getting turbulence, and that's going to break the airplane, destroy it, because the drag will be really, really, really large. Now, swimmers, what do they need to do in order to avoid the wave drag? Even if they are swimming on a slow speed, they have to propel underwater. They should not go up and down in the cross water. And then you have to have these. Have you ever questioned why do they have those floating plastics? Yeah, but there is a reason for them, is to stop the oscillation of water so that you don't have drag. Because that going up and down, if the swimmer is going there, you have two different fluids. And your velocity will really, really be different. Especially if you're about, 0.1 second, the difference between the two, swimmers, that's a big difference. So, yeah, really, they're probably trying to eliminate that oscillation up and down. Because if you have 45, that's harder for your body to go up and down. That I've never thought about it, but that's an interesting. Yeah, There's a lot of things actually into swimming that keep surprising me about how the techniques and the performance, especially when you are in the athletic, level. Interesting. But you have two fluids. You need to minimize going up and down between the two if you want to really actually win something. And then you have these lane lines to minimize the wave action, and that will create the wave drag. Does it make sense? Okay. So I don't want to go into this one. Oh, it's still here. Okay, so do you know what's the answer for this one? Yeah, buoyance force, like to the volume, correct? It's V multiplied by the gamma, right? And the gamma is, what is the gamma? It's not the density, is the specific rate, which is Newton per meter cubed, right? That's what that is. Now, a flow characterized by a smooth parallel layer of fluid is defined, which one of them is laminar flow, right? That's what it should be, right? So you can do that, and that's good. Now, here's the thing. let's take 10 minutes. There are 3 videos on D2L. Assemble as a group. All of you watch the videos. Try to come up with only 5 timestamps for each one. So 1 minute, 1 timestamp as a group. 10 minutes, and then we will solve the questions together. Write those on a Word document or a sheet of paper so that you can upload it to the D2L Dropbox in class activity. It's the lift. Yeah, 3 videos that you're going to deal with. I'm testing a lot of stuff, so let's see if anything will be useful. Yeah, by the way, guys, before you start, can I ask you a question? Quick question. If you are in sophomore year, and then Mount Union said, well, we are developing a minor in AI related to the fundamentals of AI, but no coding, and the ethics of AI, and the tools of AI related to biomedical engineering specifically for your discipline, would you go with that minor? Who says yes? Well, that's promising. I'm in a big fight with Mount Union. A huge fight, because they're pushing back on anything related to AI, especially writing and communication. They're driving me crazy. I stand up. If you go to the real world, you need to have the skill, some skills related to this. I stayed 24 hours from last night to night. I wrote 25 pages of a concept paper for a minor in AI. Okay, guys, go ahead. 10 minutes from now. Thank you for providing me with an optimistic view. And by the way, guys, make sure that your timestamp is a question. So what is this? Yeah. Good. Okay. 3 minutes to go. Okay. That is 10 minutes. We good? You have all of it? Okay. So here's what I want from you. I want to start with answering questions related to chapter 15 from the beginning to drag. Then I want you to share your questions with the group, and then we'll answer questions about lift together. This is a practice for the final exam. I'm going to answer questions today that are multiple choice and true false. Next time when we meet, I'm going to solve writing examples, some examples with problems to solve, not multiple choice or true false. Does it make sense? We good? Okay, so let's do it together. The review. We answered this one, right? It was directly buoyant force is directly related to volume. We good? Now, what flow we thought that is what flow characterized by smooth parallel layers of fluid, laminar. I'll do this. Make sense? We're good with that? Now, who wants to try this one? Not true. Go ahead. I think it's affected by the density. So it's affected by the density. It is affected by density because rho is there, right? So the formula is FD equals. So we start with what is the first element of the formula for FD? You have the density multiplied by the coefficient of drag and the area of the drag. There's one more thing. Can you check from the notes? There's one more thing left. This week, today. Yeah, there you go. So it is the 1/2 CD. So density, because it's rho, it is part of it. So that statement is true, actually. Alyssa, D. Yeah, all answers are correct. So the answer is D, because it is caused by, it's a force, correct? And it's affected by the surface area. The larger the area, the larger the force. And also the larger the density, the larger the force. So all of them are true, actually. None of them is false. Does it make sense? We good? Okay. Now, we answered this before. I don't know why it's repeated, but that's laminar flow. Anyhow, that's fine. We go to the next one. Who wants to try this one? Which of the following factors affects skin friction drag? It's friction. Remember, it's a friction drag. Yeah, so all of these answers are correct. It increases in the relative to velocity. The larger the velocity, the larger the drag. Surface area, the larger the area, the larger the drag. And the viscosity of the fluid, the larger the viscosity, the larger the drag. So all of them are correct. Make sense? Okay, next one. Who wants to give it a try? It is the form. Remember we said the form is different. We have a difference in pressure between the front and the rear of it. So that is actually a form drag. Right? The wave drag, it changes in two fluids, all going up and down against the flow of the current. Yes. So the wave drag, the wave is the one when you have the airplane, that thing that's pushing. Okay. So we have that correct. How about this one? Yep. So it's both the nature of the boundary layer depend on which of the following. The roughness. Remember when you have two layers. If you have an object moving through a liquid and it's rough, the layers around it, they will have turbulence, and then they will affect the other ones, and that's going to create a drag of the two. So both the roughness of the surface and the velocity relative to the flow. Remember we talked about the relative velocities. So what is this? The the velocity of the body relative to the flow, it is the velocity of the body minus the velocity of the flow, correct? Keep that in mind. It is the relative velocity between the two that is going to create the boundary layer, which are going to create a drag for us on the liquid. Does that make sense for us? Okay, how about this one? Yep, this is the wave drag, because you will have movement up and down in the ocean, and also you'll have different fluids. You have the air and the liquid, so that's going to create a wave drag on the subject. You are getting it perfect. Now, how about this one? That was from last lecture, Mondays. Was that? So which explain the buoyancy is the Archimedes, because Archimedes said that a body float if the volume of liquid that is moved equal to the volume of the body. And remember, the buoyant force depends on the volume. So that's correct. Make sense? Okay. Next one. So which of the following identify velocity of a body with respect to velocity of the wind? Yeah, that's relative velocity as well. Anything that is with respect to something else, that's a relative velocity. Now, here's the thing. A lot of biomechanists, when they do analysis for a sport or for testing, they mess up the relative velocities. And then the calculations and testing will be all wrong. So make sure that you know that. Okay, about this one. Which of the following statement is always true? Always. Yep, center of volume is always the center of buoyancy, right? The center of volume will be the center of mass if the subject is floating without any other forces acting on. So the weight is at the same line with the buoyancy force. So the buoyancy force is up, the weight is down. That's the only time when that is the same, right? So, yep, center of volume is the same as the center of buoyancy. We're good. How about this one? For floating to occur, which of the following must exist? B, the buoyancy force must equal to or exceed the weight. Absolutely. And we solved the problem about this, right? We did that together. Okay, how about this? Oh, now these questions, we're going to solve them together Friday, because there was, we need to do some calculations, and I want to make sure that we do this correctly. So I will leave those till Friday, but you have access to them, so you can look at those if you want to. Now, what I want to do is solving this, the list of problems that they are related to what you've watched, correct? So each one of you will be an expert in one part of it. So let's say, and you need to explain the answer for the group to make sure that we are all on the same page. So let us start with this. Cyclist drafting will minimize form drag. How is this true or false? And drafting is when the cycle changes there. A cyclist drafting will minimize form drag. Oh, it's a form drag, because when the body is big, you'll have turbulence. Oh, but still, you are minimizing the difference in pressure between the two. So drafting is following, or is it? It's not when you are. Yeah. Oh, you have turbulence behind the subject. Well, it makes sense. So if you want to really simplify it, is it reducing drag in general? So that's true. We'll go with that. Yeah, I'll go. Yeah, no, that's good. But still, you have a lot. We will do the drag itself. We cross the fault to make sure that this is easy. Okay, we good with that, guys? So drafting reduces drag or minimizes drag. Is that correct? A cyclist drafting. That's correct. Cyclist drafting minimizes drag force. Okay, now discuss the Magnus effect. Provide examples. Who did that? Which group did the Magnus? So what happened with that? So what happened with the? So what happened is that the pressure up or down. Where is the pressure is larger? Top. And so what happened is it going to go up or down? It's going to follow the pressure. So is it going to flow up or flow down? If you have higher pressure on the top, so that's the whole effect is if you have a higher. So if you have this ball like this, and if you have P here and P there, depending on which one is larger and which is smaller, that is going to spin toward the larger force, right? You can double check, but that's actually the Magnus effect, which is how are we going to control the spinning? Now, here's what happened. If it's spinning upward, it's going to go up. If it's spinning downward, it's going to go down. And that's the same also for pitching in baseball. You can control the spinning, and that's going to control the pressure. And you're right. If you have if it's spinning this way, and so the wind is going there, or the flow is in the other direction, that's going to allow it to go up or down depending on the difference in pressure. So when you watch the videos, pay attention to where is the pressure larger, and it's going to cause it to move up or down. That's the Magnus effect. We good? Makes sense? And an example, the baseball or the golf. And there is a reason why they are designed actually this way. So the golf club and the ball are designed so that it goes always up. Does it make sense? So that you can spin and it goes up with the other one. That allow it to spin there. So, does it make sense? We good? Okay. That is about the lift. Now, multiple choices. Golf clubs are designed to impart backspin, which affects the ball in what way? It increase in flight time, increase in range, both increase in flight time and an increase in range. None of these answers is correct. See, it's doing both of them, right? It's allowing it to go up. So it is increasing the flight time and increasing the range because it spins up the thing with the Magnus. Okay, a curved ball pitch follow which path? Straight line with sudden break at the end. Smooth arc can be either straight line with sudden breaks at the end or smooth arc. None of this. A curved ball. Yeah, it has to go through a smooth. It will spin, right? But it's going to be a smooth line for it to do that spinning. And that's important. So when I did my master's, we worked on something like this, understanding the tennis spinning ball, the tennis ball spinning for a subject who has injury, and they design something, use the different technique to perform the serve. Yes. So the golf club are designed to impart backspin because backspin is going to so if it's doing backspin, it's going to go down, right? Backspinning will go down. The other one is upspin. Is that what they call it? Topspin. So backspin and topspin. That's you want it to go up, not down. Okay. Topspin on a tennis ball will have what effect? The topspin. Ball will drop sooner. Ball will rebound lower. The ball will rebound faster. Both ball will drop sooner and ball will rebound lower. All of these answers are correct. Again, topspin. The ball drops sooner. The ball will rebound lower. It's correct? It's going down. And the ball will rebound faster. It's going down faster. And also both will drop sooner and drop lower. All of these are correct for the topspin on a tennis ball. Which of the following is considered a foil? Do you know what a foil is? You know the picture that I showed you that you have something like this and you have air flowing? The first slide that I showed about lift, that is actually a foil. So human hand, is it a foil? Yeah, because it has this curvature in the front and curvature in the back, right? Just like a wing of an airplane. So that's correct. Discus. Yep, right. It does have that foil. Both human hand and discus. That's a question. That's the answer. Both of them. Now, foil. I don't know if there is a lot of people who can develop foil from paper, right? For games and stuff. When you throw something out. Okay, that's it. That's all what we would like to discuss. These questions that I told you about, I'm going to put them also on the PowerPoint so that you have access to those. The one that I said to you. But I wanted you to watch the videos, talk about it, and then get an idea about that thing. Before we leave, I want you to share the questions that you had from each video. So what is the formula for the force? It's not volume, it's velocity. Yeah, small v. Good. Next, the second group, the second video. And the angle of attack, the larger the angle, the larger the... then we will have... Okay, guys. Hopefully this was a good exercise in doing this. And we learn more about lift and drag. Make sense? Okay, I will see you tomorrow in the lab, and we'll keep moving forward.